Good day everyone, and welcome to the unit focusing on the maintenance and safety of electric vehicles and their batteries, which is part of the training course on electric vehicles brought to you by the Smart Energy Solutions for Africa, or SESA project. My name is Alvin Mejia, and I work for the Urban Electric Mobility Initiative. In this unit, you will learn about the basic technological components of electric vehicles, which are highly relevant when we talk about maintenance and safety. We will talk about the risks that are associated with electric vehicles and their batteries, and we'll build the case for proper maintenance practices and systems as building blocks for e-mobility. We will focus a bit on electric vehicle batteries from the angle of safety, and finally, we will look into basic maintenance concepts and practices towards ensuring the safety of the electric vehicle, their batteries, and components. Let's first talk about the electric motor. Electric motors utilize electricity and magnetic fields to generate rotary motion. Electric motors can essentially only have one or few moving parts as opposed to hundreds in conventional engines. In essence, the maintenance burdens that come with complex internal combustion engines and their moving parts are eliminated in electric vehicles. This results in clear advantages for electric vehicles when it comes to maintenance requirements and maintenance costs. Moreover, magnetic fields are very gentle, and electric motors can essentially last for very long times and can be very efficient as compared to the ICEs. For example, estimates says that the battery electric cars can only have a third of the energy and maintenance cost versus their conventional counterparts. The other fundamental technological feature of battery electric vehicles that I'd like to talk about today, of course, are the batteries. While electric vehicles have the advantage in terms of its motor, they are essentially at this disadvantage when it comes to energy storage. In terms of energy densities, for example, lithium batteries can only hold a fraction of what liquid road fuels can carry, and thus we need to have multiple packs inside the vehicle. You must also remember that the battery is an electrochemical storage device wherein energy is stored in chemical form and can come in different chemistries such as lead acid, nickel-based, lithium-based, among others, and each comes with its own advantages and disadvantages. Given the complex nature of electric vehicles, particularly of their batteries, they have been linked to specific risks such as the ones shown in this slide. Electric vehicle fires have been documented across the globe considering different situations, such as while the vehicle is parked, fires when they are being charged, being driven, or incidences related to road crashes. There have also been documented instances of spontaneous combustion or fires due to improper charging practices. Lithium-ion batteries, which are the most popular EV battery chemistries to date, are highly flammable and can cause fires if damaged or improperly handled. The two photos on the upper portion of the right hand of the screen shows a brand new electric bus which suddenly caught fire while being parked after passing a road test. The incident happened in 2015 in Hong Kong, and it was suspected that there was a compromise in the sealing of the battery casing right after the performance inspection was done. On the bottom part, you will see an electric vehicle that caught fire during a charging process, which was thought to be related to the vehicle's onboard charging equipment. Aside from fires, electric vehicle charging and associated charging facilities can pose electrical hazards, which can include potential electric shocks to users, as well as electric shocks to workers. High voltage systems used in electric vehicles can also cause electrocution if not handled correctly. Short circuits in the electrical system can also be a hazard, particularly if the vehicle is not up to standard or not properly maintained. EVs, like any other vehicle, are also susceptible to road crashes. The key insight here is that in many developing countries and cities, particularly, the risks in terms of road crashes involving electric vehicles and be highlighted by the lack of proper regulatory regimes when it comes to electric vehicle registration, roadworthiness, and enforcement of standards. While it is quite obvious why we need to properly maintain electric vehicles and their batteries, it is sometimes overlooked. Proper maintenance systems and practices ensure the safety of the direct users, such as the drivers, the passengers, as well as the workers in the garages and workshops. Should take into consideration maintenance practices are the first line of defense for protecting the users, who may not be experts in terms of e-vehicles. And secondly, we also have a responsibility towards other users of the road, as well as the energy infrastructure that the electric vehicles are tapping into. Finally, proper maintenance practices ensure that we realize the benefits of transitioning towards electric mobility in terms of upholding the performance potential of the vehicles, their longevity, as well as their cost effectiveness against conventional vehicles, and ensure that we adhere to the sustainability goals that we ought to contribute to. Battery safety risks are amplified because of thermal abuse, physical damage, and charging and discharging malpractices. Avoid extreme temperatures if possible. High temperatures can result in unwanted chemical reactions and overheating. Poor thermal dissipation can trigger thermal runways, which can lead to fires. Cold temperatures can increase internal resistance, which promote dendrites and cause additional heating effects. Batteries are relatively fragile without the shells of the vehicles protecting them, so always ensure that they are protected from physical damage, particularly if they are taken outside the vehicle for whatever purpose. When charging, practices do not adhere to the predefined procedures and exceeding limits in terms of the speed of charging, the total amount of energy to be charged, the risks increases, such as overheating, internal faults, and the performance and lifespan of the batteries will be affected. In many EVs, electrical abuse would be mitigated if the battery management system is properly designed and functioning properly. Self-ignition and spontaneous ignition incidents are more related to poor manufacturing, inadequate electronic control systems, BMS poor design, and make sure that the batteries and the components, for that matter, are compliant with compulsory performance and safety standards. I would like to remind everyone that battery management systems play a critical role in the maintenance of the electric vehicles as they control and monitor and protect the battery pack. Here are some maintenance basics for ensuring the safety of the EVs and their batteries. First, maintenance systems should consider the vehicle as a whole, considering the electrical system, system functions, and the battery. Regular inspection and routine maintenance timelines, adhering to the manufacturer's standards is very important. Work with your suppliers and follow their instructions. Same goes with the charging equipment and charging procedures, and they should be included as well in terms of the regular maintenance schedules. The BMS should be kept up to date and calibrated, and this must be done in cooperation with the supplier or the manufacturer. One other thing that the EV owners and fleet operators can do is to properly monitor the performance of their vehicles, to document any issues and document them properly. Spotting telltale signs of degradation or breakdown and addressing them together with the supplier or experts would be key steps towards making sure that the vehicles and the batteries work properly. Finally, it would be worthwhile to look into investing into training, particularly for fleet operators who own multiple electric units. The provision of such training towards their own staff could be requested or embedded through the equipment or service provision contracts with suppliers. Maintenance, one can say, is the primary tool within the control of the owners or the operators towards ensuring the safety of electric vehicles. This would be true whether the vehicle is actually electric or not, but in the case of electric vehicles, maintenance is a necessary component for ensuring that the vehicle delivers the benefits that are expected of them. You may find other valuable references on the topic as contained on the list on the screen. I hope you had enjoyed the presentation and somehow learned a concept or two. I appreciate your time and your patience. Thank you very much and have a nice day.